Good afternoon, Dr. Rohila, my supervisor, my co-supervisor, Dr. Anwar, and my examiner, Mr. Tachana. This is my final year project topic and my final presentation, which is an investigation into smart healthcare monitoring system in an IoT environment. So these are my contents, where I'll be talking about the abstract, problem statement, scope of study, research questions, hypothesis, and a literature review, methodology, preliminary results, discussion, Gantt chart, and conclusion. So moving forward, this is my abstract, where in the there are long waiting hours at the hospital, which is a traditional medical checkup way, where the emergency patient doesn't have enough time for like medical checkup and stuff, so they end up like without getting checked, they end up like dying and stuff, especially for cardiac patients, and patients are not well taken care of by the doctors. But if we use IoT based patient monitoring system using Raspberry Pi, there is a good connection between the doctor and the patient, and they can interact through social means. So firstly, the sensor record all the values of the patient. All these values are processed in the Raspberry Pi. If the sensor value is greater than the threshold value, a notification is sent to the doctor. Uh, Likewise, the doctor can prescribe the medicines and give feedback to the patient immediately, and all the data is stored in the database. So this is the abstract. So moving forward, this is my objective, which is to implement an IoT-based patient monitoring device that monitors the temperature of the body, pulse rate, and blood pressure. To measure the patient's pulse rate, temperature, and blood pressure using Raspberry Pi, to store patient's reading of the sensor in the cloud database with the help of Raspberry Pi. So moving forward, this is my problem statement. So when a patient visits a doctor, there is always a long waiting line even in the emergency room to get checked. If security is not provided to go through the data by the doctor, anyone can prescribe any sort of medicine to the patient. So this is my problem statement. Likewise, if we have authentication and of user ID for the doctor to enter as well as the patient or a caretaker to enter, we can change this. And for emergency room lines and stuff, we can interact through smartphone devices where all the data is stored and the doctor can give feedback. So that is another way to overcome this problem in the world scenario. Now, moving forward, this is my scope of study. So in the scope of study, IoT-based patient smart healthcare device helps enhance the health of the patient by staying at home. Blood pressure, temperature, pulse rate, and ECG are the sensors that are used. The sensor is linked with the Raspberry Pi Model B+. The Raspberry Pi connects the reading of the patient with the database. The proposed system is detailed with its methodology and key components listed, along with its block diagram, circuit diagram, and cloud computing diagram, which we will see in the future PPT. And the flowchart of the research activity along with the project is elaborated. Then the preliminary data is added with the budget of the project fully described. This project is then concluded with a Gantt chart for FYP1 and FYP2. So moving forward, these are my research questions, which are explain requirements in getting an accurate reading, evaluate the possible challenges and limitations observed during the use of different kinds of sensors like heart sound, pulse rate, and blood pressure, compute the message to the doctor, get sent in the exact time, calculate the possible ways to have accuracy with the different measurements, explain if sensor collects the data and sends it to the cloud database. So these are the research questions. So moving forward, these are my hypotheses. So more parameters can be sensed and tracked as sensors become available as biomedical trends evolve, improving the ability of the wireless detecting devices in biomedical field. This device can be portable and easy to use. There can be addition of different sensors like ECG sensors, SpO2 sensor, accelerometer sensor. So these are my hypotheses. So moving forward, these are my literature review where I have taken 5 papers, and as my supervisor and co-supervisor mentioned, I have taken the one best paper, which is Naik and Sudarshan Mr. Nayak and Sudarshan's paper of 2019. So the title of the research paper that I found was the best was Smart Healthcare Monitoring System Using Raspberry Pi on IoT Platform. Here he has used a lot of parameters, sensors to evaluate the patient, like patient's body temperature, ECG heart rate parameter, blood pressure, electrical activity of the heart, rate of movement, and the equipments used are temperature sensor, BP sensor, heart rate sensor, ECG sensor, acceleration sensor, and Raspberry Pi with GSM, where the doctor and the patient can interact with text messages, and a notification can be sent to the doctor. So the important findings in this paper is that a doctor can review a patient's medical history and recommend medicine and prescription adjustments. Patients with special IDs and passwords have access to their records. So the limitations were data transmission is contingent on the presence of a smartphone built up. So the research gap was built up a website for the data transmission. So in all these parameters, we save the power dissipation, and this is a very relevant paper where all the parameters are used, and where we can interact with the doctor and patient in a very easy medium through different parameters, so the doctor can be updated with all the happenings of the patient. And it is very relevant in today's world where there is lack of different kinds of things in the hospital as well. And in other papers, I couldn't find so many parameters like I could find different kinds of parameters in this paper. So the doctor and the patient can also interact very nicely due to the GSM module. So that's why I found this paper very relevant. So moving forward, to the methodology. So the initial task of an IoT-based smart healthcare monitoring system, according to the workflow, is to collect the data from the patient via sensors. So after they collect the data via sensors, the value is sent, all the data is sent via the Raspberry Pi and linked to the database, so that the data is accessible to the doctors, who can use it to obtain patient information and write appropriate prescription. This indicates that if the value of the sensor is higher than the threshold value, a notification will be sent via the user application to the physician and the caregiver, and the physician and caregiver is even sending an alert message. So this is a very good way for the doctor and the patient to interact, and as well as the caregiver. So the software tools that will be used are Raspbian OS, Python language, embedded language, and wiring Pi. This will help us in interacting with the Raspberry Pi. So this is my methodology, and moving forward, these are my flowchart, where there is start, sensor initialization, where reads all the sensor values from the sensor nodes, and if the sensor value is greater than the threshold value, alert message is sent to the user app. If the sensor values are transmitted to Raspberry Pi, sensor data are stored in a file. Establish internet connection. Is the connection a success? If it is a success, then upload the file to the cloud, then retrieve the data by the user app, and then stop. Then this is another flowchart of our research activity, where there's literature review, designing module, evaluation, and detection of any errors in the device. Does the project fulfill the objective? If it doesn't, we have to optimize and refine it, or else we proceed and make the final prototype and the final report. So this is my flowchart, and these are my block diagrams, cloud circuit diagrams, and cloud computing diagrams. So moving forward, this is my preliminary data, where all the quantity and price and the total is given, and all the hardware components are listed. And moving forward, this is my discussion, where the project discusses the main objective of this proposed system is to establish a smart health device depending on the robust IoT tools with the help of microcontroller known as the Raspberry Pi Model B+. The sensor on the patient sides are to monitor the patient's symptoms. Blood pressure, heart rate, temperature, and blood oxygen are the used sensors. The data is collected by these sensors and sent to a server. The server will then process the acquired monitor data and make it available to the user, such as cloud, doctor, and caregivers, in order to detect and monitor health issues. So this is the concluding sector, where in this FYP there is more research on the theory part, where all the costs of the hardware components are covered. The proposed smart health monitoring system is briefly studied. This summarizes how Raspberry Pi works in connecting the sensor with database. Likewise, in depth with the FYP1 project and learning about the basis of the hardware and software tool. Eventually, after the completion of FYP1 report, we move forward to FYP2, where we will assemble all the hardware components utilizing the software tool. This framework of FYP1 helps us develop the prototype of this report we are working on. The cost has already been separated for the development of the prototype, and this is the Gantt chart. So everything is elaborated in the Gantt chart, where we've made the research proposal, research presentation, research proposal, report submission. So thank you so much, sir. And I have covered all the components from my contents, which is abstract, problem statement, scope of study, research questions, hypothesis, literature review, preliminary result discussion, and Gantt chart and conclusion. So thank you so much, and thank you.